Hello everyone, we're back again doing a lesson 11.2, day 2. Today we're going to talk about how to multiply radicals, although we kind of already have done that. We've only really done like a monomial, say like root 5 times root 2, another monomial, back in lesson 11.1. And we would just say that's root 10, can't break 10 down, that would be it. What we're going to see more of in this section, or this part of the section, is maybe looking at a monomial multiplied by a binomial expression, and also maybe a binomial multiplied by a binomial. And you guys will find that there's a lot of similarities between how this is going to work here and back in chapter 9 when we were multiplying polynomials together. We're going to see kind of like the FOIL method come back. Some of you might choose to use the box method here, totally up to you. I'm going to use FOIL though in the notes. And just kind of keeping in mind all the answers need to be in simplest radical form. So the first two examples are using the distributive property. First question, we have this monomial of root 5 being multiplied by the binomial expression root 8 plus 9. The reason we can't simplify that is because that term doesn't even have a radical. So that is what it is. So we're going to think of coming down here and, trying to make you guys dizzy here, throw the root 5 to the root 8. Also throw the root 5 to the 9. So root 5 times root 8, you can multiply any two radicals together that you want. You do not need a common radicand there. So you would just think of taking the radicand of 5 and the radicand of 8, multiplying those together. And you can also kind of think of there being like a 1 here and a 1 here. So 1 times 1 would still just be a 1 out in front, and then 5 times the 8 would give you a new radicand of 40. And then when you go to do 1 square root of 5 times a 9, that's the situation where you basically just push those two things together because 9 is not underneath of a radical. So 9 would then just become the coefficient on that root 5, or you can think of again kind of like you multiplied that 1 by that 9 because both of them were outside of a radical and there was no other radical to multiply that root 5 by. All right, then from there, this goes back to day 1. Can we add the square root of 40 to the 9 square roots of 5? Upon first glance, I'd say no, because we don't have a common radicand that's got a radicand of 40, radicand of 5. Let's see if we can maybe simplify one or both to get a common radicand. So looking at 40, I know that 40 can be broken down into the square root of 4 times the square root of 10. 5, I know I can't do anything with that, so I'm just going to bring that down as 9 square roots of 5. This would become just a regular old 2 out in front of the square root of 10 plus still your 9 square root of 5. So even after we did all that work over here to the square root of 40, we still cannot add those two terms together. So this right here would be as far as we could take this expression, but we do still need to do that because all of the answers should again be in simplest radical form. So 2 root 10 is preferred to just the root 40 up there. Let's try one more distributive property. So here we have another root 5. We're going to throw it to a 2 and a root 10. So again, can't multiply those together to say 10, so that 2 is going to become a coefficient out in front of the root 5. Those are both under a radical, so I can combine those under a single radical and say the square root of 50. Now I'm looking at the plus sign. Right now, no, I cannot add those, but let's see what can be done with these individual terms. And when it comes to simplifying, 5, nothing. 50 though, I know, is 25 times 2, and 25 is a perfect square. Simplify the square root of 25. Let's drag this over here. We would have 2 square roots of 5 plus, that would become just a regular 5 out in front of the square root of 2. So again, we did all that work to simplify the square root of 50, only to find out we still can't actually add, but we need to do that work to make sure that all of the terms are in simplest radical form. So this right here would be the final answer. Cannot add those together because they do not have a common radicand. That's got a radicand of 5, that's got a radicand of 2. Second situation in this part of the section is multiplying two binomial expressions that contain radicals using FOIL. So you remember the last time we came across this was back in chapter 9 when we did a lot of factoring and work with polynomials. So if we kind of go through and show here F, O, I, and L, F is going to come from doing this regular 2 times the square root of 3. So that's the situation where you would just push those two things together. because the 2 is not under a radical, but the 3 is. So that would just be 2 square roots of 3 for f, first times first. O stands for outer, so 2 times the positive 2 square root of 7, so the 2's that are outside can get multiplied, and because these are both positive, I'm going to throw a plus 4, because 2 times 2 is 4, and then you still have that root 7 tacked on to that 4. I for inner would be root 2 times root 3, so because those are both positive, again I'll throw a plus sign, and they also happen to both be under a radical, so I can go ahead and multiply 2 by 3 to get a new radicand of root 6. And then finally, last times last, root 2 times 2 square roots of 7. You can think of there being like a 1 out in front. So that 1 times that 2, they're both positive, would give us a plus 2. And then under the radical, 2 times 7 would give us a new radicand of 14. And then as I skim through here, I've got 4 different radicands, 3, 7, 6, and 14. So upon first glance, none of these can actually be combined because none of them have a like radicand. And I'm also noticing I cannot break down 3, I cannot break down 7, I cannot break down 6, and I cannot break down 14. There are no perfect square factors of any of these numbers other than 1. So this honestly, right here, would be the product of those 2 numbers. So that one did not clean up very nicely. That won't always happen though. All right, in this last example here, we have 2 square roots of 6 times 1 square root of 3. So imagine the 1 out in front, the 2 times the 1 would give you a 2. This is F in FOIL. And then root 6 times root 3 is going to be root 18. And we go outer terms. So 2 root 6 times negative 3 square roots of 6. So a positive times a negative will be a negative. And then I'm going to show this an intermediate step here. 2 times 3 is going to be a 6 in front. And then under the radical, 6 times 6 is 36. I do understand some people might just jump right to say regular 6 because a radical times itself is the radicand. Okay, inner terms, root 5 times root 3, both positive, so that's going to be plus, and then they're both under a radical, so that's going to give me a new radicand of 15. And then positive times negative is going to be another negative. For last times last, think of there being a 1 in front of that square root of 5. 1 times, down here, 1 times 3 is going to be a 3 in front, and then root 5 times root 6 would give us root 30. So again, right now, all 4 of these are different. What can we do with 18? We can rethink of it as root 9 times root 2, because 9 times 2 is 18, and 9 is a perfect square. We'll come back and clean that up in a minute. Minus, bring down that 6, and the square root of 36, that is a perfect square. So I'm just going to replace that with a 6. Plus, pretty sure 15, the only factors of 15 are 1 and 15 and 3 and 5, so nothing can be done to break that down. And then minus 3, when it comes to 30, same thing, 1 and 30, 2 and 15, 3 and 10, that's it. Nothing is a perfect square other than 1, so that number is stuck. So if I come back and basically clean up these 2, the first 2 terms, F and O, square root of 9 is 3, 2 times 3 is 6, so out in front of that root 2 I now have a 6. This is just going to be minus a regular old number 36, plus the square root of 15, minus 3 square roots of 30. So we cleaned these 2 up, but still none of these terms can be combined because none of them are like radicals, and this term here isn't even a radical anymore. So the answers are not pretty, but that would be the simplified version of that product. So go ahead and try out a couple more practice on the CUDA math worksheet, and then as always, just don't hesitate. If you have any questions, shoot me an email. Good luck.